Fraunhofer lines. Yeah. Dark lines in sun spectrum called Fraunhofer lines. Fraunhofer, the scientist which discovered these lines. These lines represent, the answer is, represents the element that present in sun atmosphere. So Fraunhofer discovered these lines, and these lines represent the element which is found in the atmosphere of the sun. This element, it will make the dark in our spectrum, in solar spectrum. So these lines represent the element which is found in the atmosphere of the sun, and Fraunhofer, the man which discovered these lines. And another?
Okay, the optical fibers may be used in a transportation of light.
Optical fibers we know that the scientific idea of optical fibers based on the critical angle. When the light rays enter to it with angle more than the critical angle, it will be totally reflect. So optical fiber is used to transport the light from one point to another, because the rays suffer successive reflection, because the angle more than critical angle. So when the ray enters to the fiber, the rays suffer successive reflection because the rays has angle more than critical angle, so it will totally reflect, and the fiber will transport the light from one place to another, as we know in endoscope.
Okay, the induced electromotive force in a coil increase of its core is made of soft iron.
We know that when the EMF in dynamo, EMF equals NAB omega. So if the core made of iron, because the iron will concentrate the magnetic field, because iron has great magnetic permeability, mu. So the core of the coil of dynamo made of soft iron, because soft iron concentrate the magnetic field, and iron has great magnetic permeability, so increases the induced EMF in dynamo.
Mention the factor affecting each of the following. The wavelength of the wave which accompanies a moving particle.
When a moving particle, or the moving particle, lambda of moving particle equal h over mv. This is the Broglie equation. Any moving particle is accompanied by a wave motion, so wavelengths can be calculated from the relation lambda equal h over mv. So wavelengths depend on mass and velocity, or we can say momentum. The relation between momentum and the wavelength is inverse proportional. So the factor affecting on the wavelength of the moving particle is momentum or mass and velocity, lambda inversely proportional to b. So as momentum increases, the wavelength decreases.
The distance Y between any two successive similar rings in Young's experiment.
In Thomas Young experiment, delta Y equals R lambda over D. What's meant by delta Y? Is distance between two successive dark or light rings. So delta Y inversely proportional to the distance between the two slits, and delta Y directly proportional to R is the distance between the two slits and the screen. So delta Y is inversely proportional to the distance between the two slits, and delta Y directly proportional to the distance between the screen and double slits. So the factor affecting on delta Y, two factors only: the distance between the screen and double slits, and also the distance between the two slits according to the law.
The induced EMF produced in the coil of the dynamo.
Induced EMF in the coil in the dynamo, we can return to the rule of EMF. EMF equals N A B omega sine theta. So induced EMF depend on, or the factor affecting on it, number of turn, area, and magnetic flux density, and the angular velocity. And theta must be 90 to obtain maximum EMF when the coil is parallel to the field. Coil is parallel to the field. So the factor affecting on EMF in dynamo: number of turn, area, magnetic flux density, and the angular velocity, and also the angle of the coil.
Mention without explanation the common elements, components in the production of laser devices, and why the helium neon have been selected in the helium neon laser.
The common element which is used in laser: helium and neon. We can obtain laser from any material, from solid or liquid or gas or semiconductor. So laser beam, we can add to this answer, laser can be obtained from solid, liquid, gas, semiconductor, and why we use helium and neon? Helium neon, He and Ne, are very closed from metastable state of energy level. So we know that helium is a source of energy. It gains the energy and gives it to neon atom, and neon atom reaches to inversion population. And now
Convert 61 from decimal system to binary system.
we want to convert 61 to binary system. 61 decimal system. 61 is decimal system, and we want to convert it binary system. This is a scientific idea of digital electronics. We convert it now. 61 divided by 2, you can write it again. 61 divided by 2 equals 30, and the remaining is 1. Divided by 2 equals 15, and the remaining is 0. Divided by 2 equals 7, and the remaining is 1. Divided by 2 equals 3, and the remaining is 1. Divided by 2 equals 1, and the remaining 1. Divided by 2 equals 0, and the remaining 1. So that digital or the binary system is 1 0 1 1 1 1 1 2 This is the binary system for 61 decimal. We convert decimal into binary system. This is a scientific idea of digital electronics. So is 1 0 1 1 1. And also we can convert from digital electronic to decimal as shown in the next question, which is
Convert 10 10 from binary system to decimal system.
10 10. We will convert it from binary system to decimal. So 0 times 2 power 0 plus 1 times 2 power 1 plus 0 times 2 power 2 plus 1 times 2 power 3. This equals 0 and plus 2 plus 0 and plus 8. We can add 0 plus 2 plus 0 plus 2, 8 is equal to 10. Now we convert the binary system into decimal. This is the way how to convert from binary system to digital to decimal, and how to convert from decimal to binary system.
Draw Dewar's flask, then state its usage.
Dewar's flask. Dewar's flask is used to store liquefied gases. As helium and neon. The draw is double wall flask, between them reflected surface, and also vacuum to reduce, to decrease the heat lost by conduction and convection, also radiation, to keep this liquefied gas at the same temperature. So Dewar's flask is used to store liquefied gases as helium and nitrogen, or nitrogen, as shown in the figure. And another question.
What is the necessary modification to use the moving coil galvanometer for measuring unknown resistance by direct method?
We want to convert how to convert moving coil galvanometer into ohmmeter to measure resistance. We must understand the questions. First, we connect the galvanometer with a battery or a cell of constant EMF, and also we connect it with variable resistance and with standard resistance. So galvanometer connected to standard resistance and variable resistance, and there is a test terminal for measuring any resistance. If we want to measure any resistance by using ohmmeter, the pointer of galvanometer must give full scale in order to give zero resistance in external connection. So to convert a moving coil galvanometer into ohmmeter, we connect it with a standard resistance and a battery or cell and a variable resistance. All of them are connected in series. All connected series. We can add another question from me. We can convert a meter, galvanometer into a meter. Galvanometer into a meter. We connect with it shunt, which is a small resistance in parallel. It is rule RS equal RG IG over I minus IG. Also, we can convert the galvanometer into voltmeter by connecting multiplier, which is denoted by Rm equal V minus Vg over I. So we can convert galvanometer into a meter and also into voltmeter and also to a meter. So convert it into a meter, we connect it with a small resistance in parallel called shunt resistance. In order to convert it into voltmeter, we connect it with high resistance in series called multiplier. And also, if you want to convert galvanometer into ohmmeter, we should connect it with a battery of constant EMF and standard resistance, and we can also use variable resistance. All of them are connected in series.
The following table shows the relation between the inverse of the wavelength of a transverse wave which propagate the same medium and frequency of its wave.
Yeah. This is a graphical representation between the inverse of wavelength and the frequency. And he said in the graph, we should draw the frequency on y-axis and the inverse of wavelength on x-axis according to the draw, which I will draw it. First, in y-axis, we draw the frequency, and in x-axis, inverse of wavelength. The table is one over lambda, inverse of wavelength, and the frequency. 25, 50, 75, 100, 125, and 120 frequency, 240, and A unknown, and 480, 480, and 720, 720. We want a graphical representation between the frequency and 1 over lambda or inverse of lambda. The graph should be drawn as shown. First, the scale must be uniform. This is the origin, and we start with the inverse of wavelengths. The first, we start with 0 and 25, 50, 75, 100, 125, and so on. So the scale in this case is uniform. The origin is 0, and we increase 25, and then 50, then 75, then 100, then 125. And in frequency, we start with 0 and 80, and 160, and 240, and 320, and so on. Each centimeter with 80. So by drawing this graph, it will be straight line as this. The slope is slope equal delta y over delta x. It means equal delta nu over delta 1 over lambda, which is equal to 480 minus 240 from graph over 100 minus 50. This equal to 480 meter per second. So the velocity of wave velocity equal 480 meter per second. And then we can find the value of A. From this graph, by knowing the frequency and the inverse of wavelengths, we can find the velocity of wave by getting the slope of this straight line, which is equal to 480 meter per second. This is the speed of the wave. In the graph, the scale should be uniform, 0, 25, 50, 75. We increase 25 in each time, and also in y-axis we increase 0, 80, 160, and so on. So the graph at any drawing must be, the scale is uniform. And we get the velocity of wave, and also we get the frequency. This is the end of this exam. And also we will move to another question. From this circuit, as shown, two 8 ohm in parallel, and key and voltmeter V1, V2, and connected to another voltmeter which is connected to voltmeter V1, connected to battery of EMF 6 volt, VB equals 6 volt, and a meter. All of them are connected in series. Find the circuit shown in the figure. In the opposite figure, find the reading of A1, a meter, A1, and V1 and V2. Then we can find first when the key is open and when the key is closed. I equal VP over R plus R equal VB equals 6 over 8 plus 2. The internal resistance equal 2, which is equal to 6 over 10, which is equal to 0.6 ampere. This is in case of circuit is open, key open. And V1 equals VB minus IR, which is equal to VB equal 6 minus 0.6 times 2, which is equal to 4.8 volt. When key is closed, I equals VB over R plus R equal 6 over the total resistance equal 4 plus 2 equal 1 ampere. Then V1 equals VB minus IR equal 6 minus 1 equal 5 volt. And V2 equals IR equal 1 times 4 equal 4 volt. This is the problem. And we have another problem. Two coil current, E current, carrying straight wire, is formed as loop. Once from one turn. The straight wire comes the loop from one turn, and another time from 4 turns. 4 turn. The first 1 turn and the second 4 turns. Compare between the flux density in center of the two loops of the loop in two cases. We know that B1 over B2 equals N1 over N2 times R2 over R1. Then equal N1 over N2 times L over 2 by R2 times 2 by N1 over L. Then N1 square over N2 square is equal to 1 over 4 all square, which is equal to 1 over 16. Let's move to another question. From kinetic theory of gases, prove that Ke equal 3 over 2 kT, where K is the Boltzmann constant and T is the temperature in Kelvin. Starting with P equals 1 over 3 rho V squared. Rho represents density and V represents velocity, square of velocity, and rho density, and P pressure. So we can start the proof. P equal 1 over 3 rho V squared. Then P equal 1 over 3 rho N A M over volume. This equal to the density times V squared. Then P V volume equal 1 over 3 N A M V squared. We know that BV equal RT. Then RT equal 1 over 3 N A M V squared. We can divide it by NA. R over NA is equal to K. Then KT equal 1 over 3 MV squared. Then 3 KT equal MV squared. Then 3 KT equal MV squared by multiplying by half. Then 3 over 2 KT equals half MV squared. So kinetic energy equals 3 over 2 KT. So at 0 temperature or at 0 Kelvin, the kinetic energy is vanished. This is the proof. The kinetic energy is equal to 3 over 2 KT. So at 0 temperature, the kinetic energy is vanishes. Also, the kinetic energy is vanishes when the velocity of the molecule is equal to 0. Let's move to another question about Compton effect. Compton effect. To prove that, force equal to P over C. P represents power and C represents speed of light, and F is the force. If we want to prove this, we want to prove that photons has dual nature, It means we can consider it wave and particle. This is a proof of Compton effect. We shall start with the proof now. Suppose we have a photon of gamma rays collide with electron. We find that the electron, its velocity will be changed and its direction changes. Also, the photon will change its velocity. Momentum of photon equals h nu over c. That's before collision. After collision equal negative h nu over c. Then total change of momentum equal 2h nu over c. So force acting, or we can write it rate of a change of momentum, rate of a change of momentum, which is Newton's second law. Then force equal 2 mc 2h nu over c times phi l. Phi is the number of photons passes in 1 second. So force equals 2 h nu over time times 1. Then force equal h nu over t. It means energy over time. It's equal to power. Then 2p over c. Then the force equal 2p over c. This force is very small. Because c is very great, 3 times 10 power 8 meter per second. This is Compton effect, which proves that the photon has dual nature. It means we can treat it as wave and treat it as particle. As electron, it has also dual nature. It can be considered as wave and as particle. And let's move to another question and compare between first refraction and diffraction. The comparison between refraction and diffraction. Refraction, when the light wave transfer from one medium to another, the velocity of the wave will be changed. And in case of diffraction, it means the bending of wave around the narrow slits. Between refraction and diffraction, refraction, when wave travel from medium to another, but diffraction in the same medium. In case of refraction, velocity changes, and in case of diffraction, velocity is constant. So the big difference between refraction and diffraction. Another comparison between interference, constructive interference and destructive interference. Constructive and destructive interference according to path difference. In case of constructive interference, path difference equals m times lambda, and in case of destructive interference, path difference equal m plus half times lambda. In case of constructive interference, crest meet crest or trough meet trough, and in case of destructive interference, trough meet crest or crest meet trough. That's in transverse wave. Another comparison between AC and DC. AC current, alternating current, and DC current. AC current change in direction and magnitude, but DC constant in direction and magnitude. The source of AC dynamo, and the source of DC a battery. Another comparison may be between step up transformer and step down transformer. Step up transformer and step down transformer. In a step up transformer, number of turns of secondary coil greater than number of turns of primary coil, and in a step down transformer, number of turns of primary coil smaller than number of turns of secondary coil. Smaller secondary coil. Step up increases voltage and decreases current, but step down decreases voltage and increases current. Both step up transformer and step down transformer work with AC current, because AC current variable in magnitude and direction, and also it gives a variable magnetic field. Transformer does not work with DC current because DC current has constant magnitude and constant direction, so it gives a constant magnetic field, so it does not work a transformer, but AC works the transformer. In a step up transformer, we use it near power station because it increases voltage and decreases current, so it saves energy. And in distribution zone, we use the step down transformer because it decreases voltage and increases current, and protect the electrical devices or domestic devices from damage. Let's move to another comparison between Fleming left hand rule and Fleming right hand rule. Fleming left hand rule and Fleming right hand rule. Fleming left hand rule to find direction of force acting on wire in magnetic field. Of course, carrying current. But Fleming right hand rule to find direction of current. To find direction of current, we can mention Lenz's rule. Lenz rule, which is direction of induced current opposes the change producing it. We can explain this by using this circuit. We have a coil. This coil is connected to center zero galvanometer as shown in the figure, and we have a magnet as shown in the figure. The north pole is near from the coil and the south away from the coil. So when we close the north pole near the coil, we find that the flux lines are cut by this coil. So it will produce induced EMF, which induce a current. This current make this coil having polarity. Polarity, it means it will convert into magnet. So the top of coil will be north. So when the magnet try to enter this coil, it make repulsion or it make resistance. And at the moment when we remove the coil from the magnet, we find that the top of the coil will be south. So it will attract the magnet. And this is the explanation of Lenz's rule, which is the direction of induced current opposes the change producing it. And also to find direction of induced current. Another question. Pascal principle. Pascal principle, which is when a pressure is applied to an enclosed liquid, pressure is transmitted undiminished to every part of the liquid and to the wall of the container. If we make a pressure on an enclosed liquid, this pressure will be transmitted through all parts of the liquid and to the wall of the container. So the hydraulic press is the application of Pascal principle. Hydraulic press or hydraulic brakes also, the application of Pascal principle. Application of Pascal principle. As shown in the figure, we have two pistons. The first is a small piston and the second is large piston. The liquid confining between them, suppose oil, and if we make a pressure on a small piston, this pressure will be transmitted to the large piston, and we can carry any heavy load on the large piston. So the pressure on a small piston, P small, is equal to P large. That means all the pressure which act upon a small piston will be transmitted to the large piston. So from this equation, P small is equal to pressure on large, then F small over A small, that means the pressure on the small piston, is equal to F capital letter over A capital letter. All the pressure is transmitted undiminished to every part of the liquid. Something is called mechanical advantage. Mechanical advantage, it is the ratio between the force acting on large piston to the force acting on a small piston, or area of large piston to the area of small piston, or radius square of large piston to the radius square of small piston, or distance moved by small piston to the distance moved by large piston. So we can pressure on large to pressure on small, the ratio between them is 1 to 1, and work done on small to work done on large also equal 1 to 1, because energy neither created nor destroyed, so the energy which applied on the small piston is transmitted to the large piston, so the energy does not change in the two cases on a small and the large piston. But the pressure acting on a small piston is equal to the pressure acting on the small piston, so the ratio between them is equal to 1 to 1, as the same the ratio between the work done on the small piston to the work done on the large piston is equal to 1 to 1. In Pascal principle or in hydraulic press, we use only liquid, because liquid incompressible is does not able to be compressed. But we cannot use gases, because gases is compressible. All gases are compressible. So most of the work done is consumed to close or to decrease the distance between the molecules of gas. So gases are not used in hydraulic press. And after this, we remove to another point. Barometer is a device used to measure PA, atmospheric pressure, and also to measure altitude. So barometer is used in measuring atmospheric pressure and altitude or heights. Some device is called altimeter. So the rule which is used to find the altitude, which is rho mercury times H2 minus H1 equals rho air times H. H represents height. H2 reading at bottom of mountain, for example, and reading H1 reading at top. Any problem, the given for all the problem, it will be you need to find one thing from this law. Rho mercury H2 minus H1 equal rho air times H. We can find the height or the rho air and reading at top or reading at the top or reading at top or bottom or rho of mercury. And in gas laws, first law, Boyle's law, pressure is inversely proportional to volume. Then mathematically we can write P1 V1 equals B2 V2. We can use this law if we have, this is an example for a problem, if we have two bubbles, one of them is equal to its volume V2 at depth H, and this bubble at the surface of water, its volume V1, and the temperature does not constant. By applying this rule on this example, P1 V1 is equal to B2 V2. P1 is equal to BA times V1. This is at the top is equal to B2 BA plus rho GH times V2. We can find the volume at the bottom or the volume at the top of this surface by using gas law. We can also use general law of gas. P1 V1 over T1 equal P2 V2 over T2. We have a container. At the bottom there is a bubble of volume V1 and temperature T1 at depth equal H, and its volume at the surface is equal to V2, and water and raw water is given. So find the volume of the gas at the bottom of this vessel. So we can apply the general law of gas. At the top, PA times V1 or V2 over T1 equals at the bottom PA plus rho GH times V2 over T2. This at top and this at bottom, so we can find the volume of this bubble at the bottom or at the top by using general law of gas. Another idea we must concentrate in it, the rule which we can find current intensity. Current intensity I equals Q over T, Q which represents charge and T represents time, the unit of current intensity coulomb per second. Also we can find the number of electrons. Number of electrons is equal to Q over E. Q represents charge and E represents charge of one electron. So potential difference, which is denoted by V, equals work over charge. It is unit joule per coulomb. If we have the potential difference and the charge, we can find the work done. The work done divided the charge is equal to potential difference. And also resistivity rho equals R A over L, and conductivity L over RA. What are the factors affecting on resistivity and conductivity? The two resistivity, both of them, resistivity and conductivity, depend on the type of material and temperature. Depend on temperature and type of material. Let's move to another point. When light falls on a surface of metal, electrons are emitted. Due to the frequency of this light is greater than the critical frequency, as the law of Einstein, which is E equals work function equal h nu c. So the light which is incident on the surface of metal, its frequency greater than the critical frequency, and the work function is equal to h nu c. Nu c, it represents critical frequency. And the energy of emitted light, energy of emitted light must be greater than work function, as shown in the equation. H nu, this is the energy of incident light, is equal to h nu c, this is work function, plus half mv squared, the kinetic energy which make the photon, or which make the electron comes out from the surface of the metal. So h nu is equal to h nu c plus half mv squared. Can I write it again? H nu equals EW, which is work function, plus half mv squared. This is the kinetic energy. So work function, energy of emitted light minus work function is equal to half mv squared. We can make it graphically as shown in the figure. And can write it in a new paper. And this is y-axis and x-axis. The graph will be as shown. This point, critical frequency, and this EW, work function, and this half mv squared kinetic energy of emitted photon. So h nu is equal to EW plus half mv squared. EW, which is the work function. Work function depend on type of material, depend on